third and final video, I hope. Just to conclude the last video, we have on the next page of your notes, you've got another example here in which you've got an open circle down here at the bottom, and you've got the graph of the function continues to get higher and higher. Even though there's a local maximum right there, there's a one local maximum, but the other part of the graph goes up forever, so this other part of the graph goes higher than this local maximum, so we would say there's no absolute max. And then because of the open circle down there at the bottom, there is not one real number that represents the lowest real number that this function can attain. And so we say there is no absolute minimum. Okay? And then a theorem that's really, really important is, we don't refer to it a lot, but it's one of these common sense theorems that I refer to, the extreme value theorem. If f is a continuous function, basically for now until we get to calculus, a continuous function would be a function in which you can draw the function without lifting your pencil or pen or whatever you're writing with. So if it's a continuous function, meaning, like I said, you can draw the whole graph, there's no breaks in the graph, no asymptotes or anything like that, on a closed interval from A to B. So it has an endpoint on the left and an endpoint on the right. So if that's true, then for sure f is going to have an absolute max and an absolute minimum value. So you can guarantee yourself, as long as it's continuous on a closed interval, you know that you're going to have one absolute max and one absolute min. Okay? I challenge you to find a function that's continuous on a closed interval that doesn't have both an absolute max and absolute min. Even if it's a constant function, the absolute max and absolute min are the same number, but they're still there. Okay? So, the last property of real numbers that we're going to talk about today is finding an average rate of change of a function. Okay? So there's a formula about this, and we're going to take a look at the formula really quick. The average rate of change of a function is similar to when you go on vacation, and sometimes, well, what was our average speed, or what was our average miles per gallon? So we can find those kinds of numbers, and we do those kinds of things in real life, but putting math to it, sometimes it can be a little confusing because of that notation right there, perhaps. We have the average rate of change. You might recognize that from your Algebra 1 days. That's the change in y or the change in x, and all that means is basically the rise over the run. This is the average rate of change of a function. So from A to B, you've got a function changing, and what is its average rate of change? Well, this is our formula. So you have to know what A and what B are, and we're going to talk about that right now. Okay. So here's an example. Find the average rate of change of this function, f of x equals 3x squared. So here's part of 3x squared. We know that it's a parabola, so all we're looking at is the part of the graph in the first quadrant. So in the first quadrant, we want to know from x equals 1 till x equals 3. This is really hard to see these numbers, I'm sorry. But from here to here, we see the ordered pairs 1, 3, and 3, 27. So the A happens to be the first part of the interval. A is 1. And the B happens to be the last part of the interval. That's 3. Okay? So if A is 1, I put an A there and a 3 there, sorry. That would be a 1 there. So the A is 1, the B is 3, and then the f of A would be, well, what's f of 1? Well, f of 1 is 3. So f of A is, it's 3. And then f of B, which B is 3, so f of 3 is 27. So that's where these numbers come from. f of 3 is 27. So we're just going to use this formula. F of x minus f of c. No, that's a horrible one. I don't know why they're doing that. This should be f of b minus f of a over b minus a. That's how you always see it. Okay, so change that. So f of b is 27. F of a is 3. B is 3 and a is 1. So 27 minus 3 is 24. 3 minus 1 is 2. 24 divided by 2 is 12. And so 12 would be the average rate of change. So what does that mean? Well, it just means that the average rate at which this function is changing would be up 12 and over 1, up 12 and over 1. So if you want to get from this point to this point, what's the slope? Well, you go up 12, so you're here at 3, you go up 12 to 15 and over 1. So you're at 215. And then you go up 12, So from 15, what did I say, 12, 15, up 12 is 27, and over 1 is 3. See how you get 327? And that doesn't make great video either. But nevertheless, that's the formula. Memorize that formula, and you're good to go. So I want you to pause the video. I'm also going to pause the video, and I'm going to ask you to do the example here. And again, I'm going to pause the video, and when I start playing again, it's going to show the entire solution. So you try it first. Pause now.